Good afternoon, everybody. Welcome to our Talking Timber webinar. My name is Samantha Charles, and I will be your host for the afternoon. The topic today is how timber is changing the face of the built environment. We have some great speakers this afternoon, and I'll introduce them later on. Just some housekeeping and introductions. The webinar will be recorded and available on the Sawmilling South Africa YouTube channel. We'll put those links into the chat. Then just in terms of CPD points, the South African Institute of Architects has assessed and validated this as a Category 1 activity and carries 0.15 CPD points. We will submit the attendance register to SIA, and to be eligible for your CPD points, you've got to sit around and stay for the whole session. You would have supplied us with your details upon registering for the webinar. And then if you have attended previous webinars and you haven't received your CPD certificates, please do let us know, and we'll ask Ferdinand to perhaps put his email address in the chat box for you to contact him. If this is your first webinar, welcome. We'll also put the link to our mailing list into the chat so that you can obviously be kept up to date with future webinars. And obviously, importantly, this webinar is brought to you by a number of organizations: Sawmilling South Africa, Stellenbosch University, the University of Pretoria, and the York Timbers Chair of the Wood Structural Engineering, Earth World Architects, and the DTIC. But most importantly, our title sponsor today is Universal Plywood and Timbers. So just before we start with Brad, I am going to just say that we have 3 speakers today: Shannon, Govender, Nicola, Smuts, and Leon Pienaar. So we'll hand over to Brad, and he can give us his presentation on Universal Plywood and Timbers.
Thank you, Sam, and thank you, everybody. It's a great honor and a pleasure to be here today to present our company. We've been pretty actively involved in this whole movement from the beginning, so it's great to finally build up the courage and speak. So let me start. So I've got a history of timber of 30 years, and a while back I started Universal Plywood, and it's now Universal Plywood and Timbers. My background's hardwood timber, so you know what was lacking a while back, we realized, is that in South Africa we only make pine plywood, which is really well made on the world standard. It's world class, but we lack timber species in this country. So we started searching and scouring the globe for different products, plywood products specifically, and which brought us into the plywood arena, which ultimately became engineered wood panels. And this opened up a whole new world for me and for our company. So we are primarily initially a plywood specialist group. We are the distributors for Weezer Plywood in South Africa, which is a Finnish birch and spruce plywood producer, the biggest in Europe, and also very sustainable. And we've done a number of projects with Earth World, like the Future Africa campus, where a lot of our birch flower was used in that build. And then we basically do a lot of concrete formwork plywood. So the Perrys, the Formscaps, and all the formwork erection companies use our products for the purpose of strength, for a number of high uses. So that's one of the big avenue and a big area for us is concrete formwork. And then we basically, once we had pretty much understood the whole plywood environment, and we carry all types of plywood: spruce plywood, lightweight plywood, marine plywood, birch plywood, palm plywood, poplar plywood, everything. We pretty much the biggest there. And we went into another product, which I think is on my slide. No, sorry. Before we went on to Lunar wood or Thermopine, I just want to jiggle this around a little bit, and we started importing laminated veneer lumber, which is very much high-end timber engineered wood products that I'm sure a lot of you people will be aware of. We are the agents for Styco. So we bring in big laminated veneer lumber billets of timber made out of spruce and other Nordic species mixes. Could be larch inside there too. And we can also get it made in birch as well. But laminated veneer lumber is an extruded product made in a continuous press. The engineering facilities are in the region of about 500 million euros. So it's a very top end of timber engineering. What we are restricted to is the length of the container. So we bring in 11.95 meter long laminated veneer lumber billets that are 1250 millimeters wide. For our purposes, currently, we bring in a 51 millimeter thick billet, as well as a 70 millimeter thick billet. And we rip those up with machinery that we have. But we can, just for your interest, we can import 150 millimeter thick laminated billets of LVL. So you can imagine it's used for big spanning timber frame construction, used in cross-laminated timber construction. In Europe, there's a number of massive timber warehouses made out of LVL with big spans, huge facilities, all out of timber. So possibly on my next presentation sometime in the future, I'll just look for those photographs for you. Then along with the LVL, which we use in the structural applications in South Africa, we use them for formwork, beams. We use it in the transport industry for carrying refrigerated boxes, so they hold the boxes upright. Those are pretty commercial uses, but it's really used a lot in big timber, mass timber construction. So we haven't really got to use it to its full potential in this country yet, but there's definitely potential. And if anybody's interested, please contact me. Another product that we like, modified and engineered woods. So another product that we also specialize in is thermally modified pine, which we import from Europe. This is called Lunar wood, which is on the slide in front of you. It's PFC and FSC certified, so it's very sustainable. It's very stable. The wood is thermally dried out, essentially, and moisture is put back into the timber. It becomes very stable, so it's used as a cladding timber. It's not very strong, so I'll just be upright about that. So it can be used as a decking timber, but it's really mainly used for pergolas. It's lightweight, it's stable, and it's very resistant to decay because it's dried out. There's not much insect interest, and it doesn't decay, should I say. So it's a great product. I'm sure you would have seen it around the country. That's been used a lot in South Africa. We also do all the other decking products, Masaranduba, Garapa, Balau, Kiring, which is an Indonesian hardwood timber, and South African pine, which is a very good decking timber. If we could just advance to the next slide, please. This is Novatop cross-laminated timber. So we are the agents. My partner is an owner of this cross-laminated timber mill in the Czech Republic, and our partners are the guys that run the wood conference, the Karutla Group. So they invested in Universal Plywood and Timbers about 3 years ago. So they are part of our partners, and we are the co-sponsors of the wood conference down in Cape Town. But we also represent this CLT mill out of the Czech Republic, and it's a spruce cross-laminated timber. It's the Rolls Royce of CLT. Very aesthetic looking panels. They do the flooring elements, the whole lot. So we actually are looking at a development to do Novatop CLT in South Africa. There are a number of homes that have already been built, and we've built a nursery daycare, which was sponsored by the Karatla Group to disadvantaged community here in the Cape Flats, which is a great project. I should try and get a video of that for everybody. So if you're looking at Novatop cross-laminated spruce CLT, we are the guys that can help you with that. They also make acoustic ceiling panels, which are really interesting. We, about 5-6 years ago, we supplied all the acoustic ceiling panels for the E-News conference room. That's the TV channel E-News. So for all their sound studios, they were used with acoustic wood ceiling panels. Just some interest. And then I think, last but not least, we are 5 warehouses in the country. We are in Ballito, we're in Prospecton, in Durban near the port. We have got a large facility up in Johannesburg in Kloorkop and Midrand off Allendale Road. And we have a warehouse in Bloemfontein, Old East End. And we have another warehouse in Epping, in Cape Town, Epping Industrial, where I'm currently based. In those warehouses, we have machine shops. So we offer machining services. We do CNC cutting. We do general cutting. We do laminating. And we also do, we have molders, so we can run molding profiles. We run spruce molds, different, whether it's tongue and groove mold, flooring, molding, ceiling boards, and cladding options. So we do that in Japanese cedar, we do it in spruce, we do it in lunar wood or thermopine, and we do it in clear grade pine. So clear grade pine is absolutely stunning. And if you haven't seen it, just come into one of our showrooms and have a look at it. And if you put a stain on it, it actually looks very similar to walnut, in my opinion. So yeah, that's who we are. And I think the last thing I forgot to add is that we also the agents and distributors for Seca moldings, which are high-end Austrian moldings. And we also do spruce glue laminated beams, big beams for exposed roofs, roofing structures. We supply companies like Pitch 45 and some other very big joiners down here that do large roofing structures. So spruce is a very blonde timber compared to pine, which yellows. Spruce is very white. So if you're looking for any big section timber beams, we can help you. And I think that's about it. And thank you very much for the opportunity to speak today. Thanks, Sam.
Thank you, Brad. I appreciate that. Thank you. I'd like to give an opportunity to Tafadzwa Nyazunda. She is the Director of Forest-Based Industries at the DTIC. Tafadzwa will be giving us a short welcome address and just taking you through some context in terms of why we have these webinars. Thank you, Tafadzwa.
Good afternoon, everyone, and thank you very much for taking your time to join this webinar and also just to hear what we have been up to in terms of promoting timber in construction. So I will just give the context, like what Samantha has said, of what we've been doing and also why we are here, and especially as DTIC, because when people hear DTIC speaking at these forums, they wonder, like, why are you here? And today we had a similar question because right here in Mpumalanga, and we were having a workshop with building control officers. So the reason why the sector desk from the DTIC that looks after forest-based industries is here is because by 2050, we'll be having 2 billion people living in Africa, and most expecting that people will be moving to cities. So this means that the demand for housing will continue to grow. And then at the same time, when we look at what does the construction sector do to the environment? It's contributing about 39% of the emissions comes from the construction because of the material that is used in construction. And then wood is one of the materials that has been used since time immemorial, but it's not so common here in the continent as well as in South Africa. Only about 1% of the construction, housing construction is in timber, whereas when you go overseas, it's more than 90% is actually in timber. So as a sector desk, and people could relate to what I was saying, what we were what we are trying to do here especially in Mpumalanga, because they are living next to the forest and they have experienced the number of sawmills that have closed. And the reason why some of these sawmills have closed is that the market has not been there for their products, as well as if they were there, if the market was there, possibly the price at which they were getting to that market was not competitive, and hence people would then go for alternative material as opposed to use timber. And timber has only been going into the roof trusses, and then it gets covered by the tiles or by the corrugated iron sheets, and inside there's a ceiling, so you never see them. So the work that we have been doing is that when we promote timber in construction, we are trying to increase the market for timber, at the same time the sustainability of the industry, and then at the same time we are creating the much needed jobs, especially in the rural areas or in the rural space where that raw material that then goes into the construction is coming from. And then we also are speaking to carbon sequestration. So it means that as we are growing trees, we are taking away carbon from the atmosphere, and it's an advantage. So at the same time, in this country, people do then have this perception of timber, and hence we then started. So I've talked about the jobs that we have lost in the sector due to sawmills closing, and also other, I think we've lost just in Mpumalanga and Limpopo over 2,000 since 2020 jobs have been lost. So this work is very critical for us. So what are we saying? What is the rationale for us then to promote timber to be used as a material in construction? It's a renewable material. We say it's energy efficient. It also contributes to positive health and safety. Accelerated construction is cleaner environment. When you are constructing, you can repurpose wood, you can recycle it, and at the same time, like I said, it's those jobs that are being created through the value chain, from growing the tree to manufacturing to installation. We've also recently just concluded feasibility study that was done by UP Enterprise and funded by the DTIC. And when we started this work long back, we were really focusing on we need a government to be part of this when we are building schools, clinics, houses. But what we have now seen is that only 28% of the total sector is public buildings, and private and residential buildings is actually contributing to 72%. So we need to actually now to be focusing more and engaging the developers of private settlement. At the same time, we then developed a strategy. This was around 2020. And this strategy has 3 pillars, which is the work that we need to do to create the demand for timber construction, and then also the work that needs to be done on capacity building, because we do not have, or our professionals have been trained mostly to work with brick and mortar, and now we're trying to bring in timber. So what should we do? How do we do it? This webinar is actually one of the interventions that is targeted at talking more about timber. At the same time, we are then saying, we then need to say security of supply of raw material. Do we have the timber? Should the demand be there? So hence, since 2018, this is what we can track, the work that we have been doing. And you can see there on the work that was planned for 2024-25, we've already had a successful timber conference that was held in Pretoria and funded by York Timbers as well as UP, and it was a success. This is the fourth Talking Timber webinar for the year 2024. We also have had 4 Wood Up workshops, and when I say we, I'm talking of the stakeholders that we are all working together in this timber in construction. Some of the stakeholders were mentioned by Sam when we started the workshop, and as well as the feasibility study has been finalized. I think we will be going through the necessary processes, and then possibly at some point we will have it on our website, the DTIC website, or the partners website, just to see the work and where is South Africa at. We have interesting work that is happening at the UKZN in terms of materials development. There's one project that is looking at transparent timber. I like that. So we're going to have windows that are made of timber. That is great. So, and then we do then have the demand creation and the capacity building working groups that will continue to have also workshops in addition to the webinars that are currently now happening. So what are we saying beyond the progress that has been done? Where are we going to be focusing mostly on, I think, regulatory issues? We still need to overcome those. And today we had our first workshop with the building control officers. I felt very excited to say, okay, yes, now we are here. We are talking to the people that are on the ground, that are proving your great plans and that are going to be interacting. And we actually received positive, and I'm hoping some managed to register for the webinar and they are listening to this. We've received positive, I think, reception. We had over 30 people that attended the workshop, and that was a good reception. And they're very keen, especially on the Wood Up. They want to do the free courses on the Wood Up. So we also had Green Building presenting on that. So these are the issues to deal with the perception, to say, how do we deal with the regulatory issues? How do we create the demand of timber in construction? And then here are some important links. I will post, or we will post these links on the chat throughout the webinar, so you can then go and see what is happening. If you are not yet on the Facebook group or on the LinkedIn group, we'll encourage you to do that. If you missed the conference, you can then also visit the Growing Timber Connections website and engage and look at the presentations that were done. And if you missed any of the Talking Timber webinars, you can then also visit the Sawmilling SA website and watch the webinars that have happened. So we can then listen to today's topic on how do we continue to, how are we changing the face of the building with timber. So over to you, Sam. I hope I didn't take much of your time. Thanks.
Thank you,
everybody.
Tafato, and again, thank you for the support of the DTIC. Going to introduce Shannon. Shannon is studying for a master's in architecture, at the University of Victoria. Her research is on how timber technology can be harmoniously integrated with various crafts, particularly within South African craft perspectives. Her research delves into the intrinsic value of craft within the architectural design process, examining how a craft mode approach can transform the creative process of architects. Her journey into this area stems from a profound appreciation for how traditional crafts have shaped our built environment over the centuries, and a desire to explore these traditions and how they can be preserved and evolved within contemporary architectural practices. So, handing over to you, Shannon. Take it away.
I'm Shannon. I'm currently doing my master's at UP, and I'm going to just speak about my research as well as my design this year and how it's going. So basically, it's called a critical analysis of a craft mode approach in the architectural design process. So what that means is, right now, craft is something that is a spectacle in the architectural design field, something that is looked at more as something that is interpreted as art. And the idea is that we can actually look at these indigenous knowledge systems, especially in our South African context, and interpret that into something that is more profound, that can be learned from within an on-site learning process within the architectural process that's not just based on aesthetics. So because of that, craftsmanship is very important. And why it's important is it invokes something that's a hands-on approach to how we can understand materials, building processes, and evidently innovation. So basically, craftsmanship in a nutshell is a person's ability to inherently do a job well. In order to do that, we have to understand craft in terms of its building crafts, from inception to what it can be in terms of what it is intangible and tangible, its connection to context communities, and then eventually its ecology and how renewable these resources are and how it affects people in their daily lives. So my approach is to look at tradition as a form of innovation, not just a spectacle, and something that we can translate from the material aspect to a process and then eventually to finer detail. So for this research, it delves into an approach that is called a craft mode approach, which speaks about how can we implement something that is craft mode and what consists of craft mode that we can implement within the architectural design process. And that speaks to how craft is connected to design. And right now we're dealing with a very linear process where there's a disconnect between craft and design, where right now we don't really understand the materials and processes to have exchange mechanisms for skills transfer, especially on site. So it's in understanding how we can implement that as professionals in order to understand a hands-on approach. So it deals with understanding materials, tools, and those indigenous knowledge system, and seeing how that can, or what we can extract from that to translate to fabrication and assembly. And it shows when that's done well in how you can understand a simple act like carpentry and how to know where that is valuable and where it is not. It doesn't help just mimicking something that is aesthetically pleasing without understanding how it's built and where it's most useful. The process is just as important as the fabrication. We could see this done in countries like Japan, where an example is King Okuma's buildings, where it's translated exactly in terms of that carpentry traditional craftsmanship and made into something that is digital and something that is fabricated successfully. So my project for this year is located in Ishowe, KZN. And it's focused on how you can take Zulu construction techniques and indigenous knowledge systems and translate that into something that is new, that is reinterpreted, but also respects the cultural values of the place it sits within. So within this context lies the fort, as you saw, which houses traditional Zulu history artifacts. The Vukani Museum, which is this picture right here that speaks about the history of pottery and wicker basket making in KZN, and also Norwegian missionary chapels within the area that speak about the Norwegian influence and the Christian influence within KZN as well. So all these knowledge systems are very important because they speak about how all these different cultures had an influence on the present. So it's just a question of where their values are important and how to extract that knowledge into an architecture that's syncretic, but also respectful to the context. So one of the crafts, besides that of timber, is looking at pottery and how that I've implemented that in terms of how it can be translated into a fabricated technique within 3D printing of clay, and then seeing how construction works within timber. Whereas this construction technique is not structural, but timber helps in that way in complementing it. So my design process took me in figuring out how to merge earth construction with that of timber construction. So it's site specific as well as relating to a craft that is both digital and context influential. In that sense, the craft becomes sustainable because it's all to do with the materials that you get on site, the tools that you used within the area, the people that it serves, and then how that gathers materials on site and also creates a wholesome community sector within a cultural landscape. It led me to interpret this from a perspective that kind of challenges the architectural way of thinking that's not linear anymore and looks at first principles, but also looks at a non-Western perspective and how to create an architecture that works together that's not the same. Thinking about that, you can think about how and where these crafts are useful and where they're most successful. So wicker tradition to timber construction, pottery to 3D printing, and an English fort stone construction to gabions, for example. And that's where I'm currently looking at how to consider this in terms of professionals. From the beginning to the end of the process, it's something that we can include craftsmen in to understand that there are different craftspeople in different sectors, including the architect, as well as the pottery maker and the carpenter, as well as timber collaboration. And these things work in different ways and can complement each other until the end. And then you're left with a building that considers professions and then mixes and merges different professional tools as well as professional skills from inception, from gabion foundation configuration to timber configuration, eventually to 3D Adobe printing, and then the configuration of the wicker-based roof. All comes together within a construction process that is an on-site learning process. And this is where the skills transfer element can be most valuable on the site. Eventually, I hope to have a design that speaks to a syncretic nature of all these cultures coming together that respects both professional fields as well as the craftspeople on site, and where the phasing of this technology works in how all these crafts, from stone to timber to 3D printing mechanisms, can work together technologically and traditionally as innovation. So yeah, that's this project so far. Thank you.
Thank you, Shannon, and thank you for the beautiful work that you're doing. It really is lovely to see how you are bringing in the cultural aspects and the beauty and artistic side of our beautiful country. And our next speaker, we will have a Q&A later, but if you do want to put your questions in the chat, please do. Our next speaker is Nicola Smuts, and she's a motivated architectural technologist and designer with a strong focus on computational design and biomimetic architecture. She is currently pursuing a Masters of Architecture professional at the University of Pretoria and has a rich background in both academic and industry settings, with experience in mass timber architecture, sustainable design, and architectural technology. Nicola has worked on various interdisciplinary projects, including collaborative research in Japan funded by the MEX Scholarship and hands-on architectural design projects in South Africa. She has contributed to the design and execution of residential and commercial projects, including creating technical drawing sets, conceptual mass modeling, and producing client presentations. So with that, I'm going to hand over to Nicola. Thank you, Nicola.
Thank you. Well, hi everyone. Apologies for the technical problems, but yeah, today we are going to be talking about how to make timber architecture regional. And to define regionality, I'd like to touch on a few projects that I've had the privilege to work on and learn from. They are all situated in Japan, a nation notoriously famous for its timber heritage. And what I would really like to emphasize here is how that architectural discourse is about taking traditional knowledge in timber construction and bringing that into a contemporary light. So the projects that I've had the privilege to work on, they were all done by Studio Rakura Architects, which is a Kyoto-based firm that really specializes in timber construction. So this project, Keihoku Factory, is a little timber factory made of timber, which is keeping in line with the theme of this webinar, located just outside of Kyoto. And what was interesting here was how they used kind of, traditional knowledge in dealing with seismic design and how that was turned into interesting and fun design opportunities, specifically the staircase. And as I have it, they mostly use cedar and cypress. And then the second project I'd like to touch on is a house in the suburbs. It kind of, it's reminiscent of the Kyomachiya houses that really define Kyoto as this cultural capital of Japan. What was interesting was how, compared to what I've seen in South Africa, the architectural drawing and specification documents were a lot less prescriptive. And the reason for that is that in this context, there's an extraordinary amount of skill in terms of timber carpentry. So the architect comes in and kind of creates this canvas of a building and only really communicates the architectural intent. And then from there, the carpenters come in and they know how to detail, they know how to build. So it created a much more collaborative working environment, I'd say. And then just the last project I'd like to share was House of Hanno, which is again taking this theme of leveraging traditional knowledge in terms of space making and how timber construction facilitated all of that and bringing it into a contemporary light. And with this project specifically, there was this whole story about using Nishikawa lumber, which is lumber that was traditionally transported via a river. And the architectural intent here really was to express the story of who was involved in this, who made it, who put it together, and where did this timber come from. And what I can say about all three projects is that they were designed, detailed, built, and occupied within the span of a year. And that's a timeline that's almost unheard of here in the South African context. And there's two things that made this happen. It's the prefabricated nature of timber construction and skill. Again, skill of highly trained Japanese carpenters. But the material, tool, technique, and skill context of Japan is very different from that of our own. So the question remains, so what? What does this have to do with us in this webinar and with the South African built environment at large? And to that I say that we have to remind ourselves that South Africa, or Southern Africa, has a long history of making beautiful, regenerative, and expressive architecture, and the materiality of timber has always played an integral role in its development. And in recent years, we've seen the sort of revival of these structurally efficient but sculptural form making, but specifically referring to Borges Chapel to the right. While it is regional in expressing the Cape Dutch vernacular, and it's a beautiful form, quite honestly, it's not necessarily as regional as it can be in terms of its formation process, its construction process. So what I mean by that is the form works incredibly well structurally because it's a concrete building and compression, but in terms of its constructability, it's not very efficient. So there's a disjoint between efficient form and inefficient formation processes. And this is especially true considering our context of moving towards bio-based material and trying to include low-skilled laborers in the dignified act of making beautiful buildings. What I mean by that is, like this building, for example, needs specialized laborers. So the bulk of South African construction laborers can't really tap into this type of architectural form-making process. So an alternative might be to look towards the natural world, where there is the synthesis of both structurally efficient form making and energy efficient growth processes. So here, form and formation are unified. But this is not a biology webinar. So the point that I'm trying to make is that we can transfer some of the principles from the natural world into the architectural world to create structures that's both high performing in terms of its form and in terms of its constructability. So these are called segmented timber shell structures, and due to their close affiliation to our vernacular building forms, they've become the subject of my research this year. And what's interesting about these structures is that they combine the structural efficiency of doubly curved surfaces and catenary action, but they also are efficient in terms of making and assembling and building, because you can parametrically start generating these individual planar segments. It can be pre-manufactured and assembled on site using our low-skilled laborers. So the question then really becomes, how do we optimize the fabrication performance of these structures to really make it work for our context? And when I talk about optimization and parametrically generating and whatnot, I'm referring to this data-driven design and a delivery approach where we work in this visual scripting environment in Grasshopper. And you basically, you set out a series of rules as to how you want the structure to be made. And those rules take into consideration our contextual needs and concerns. And then it produces something that you can prefabricate and assemble on site. So then the question becomes, what are we actually trying to tailor to our context? So the first thing was to understand that the South African built environment is very inefficient in terms of how much waste it produces. So what we did was we kind of generated different shell structures and nested the individual components, so the puzzle pieces that this thing is made of, nesting the different sizes and geometries onto our two CLT manufacturers' panel sizes, so MTT and XLAM. And there was a lot of interesting data that came from this. Obviously, you want to reduce your material waste, but the thing is, your material waste generation kind of contradicts what is optimal in terms of edge length. So what I mean by that is, the smaller segments you have, the better they nest, the less material you waste. But the smaller segments you have means that you have a lot more edges that need to be joined, and joinery is expensive and it's difficult and it's time consuming. So as seen in nature, an organism has to try and balance these opposing objectives, and that's similar to what we are trying to do here. And again, if you have smaller segments, yes, they nest better, but they also are much greater in quantity. And in terms of the inefficiencies of our built environment, you know, our managing capabilities, all of that, we have to find a balance between what works the best, not just in terms of one parameter, but something that works holistically across all three parameters. So really what we are doing here is trying to find the best way to segment these shell geometries and the best size for that for our context, not for the German or the Japanese context. And this considers both, you know, the issue of material wastage. It considers the issue of manufacturing. What type of machinery do we have? What type of capabilities do we have? And it considers the issue of assembly, which is about really emphasizing using low-skilled laborers, and how, you know, it's necessary for them to participate in this dignified act of making dignified structures. So we're considering it both in terms of the kind of what is internally required for the shell. It wants material continuity. It uses a kind of a digital fabrication process, and we're kind of considering that with our contextual requirements, and the intersection of all these requirements are considered through these quantitative parameters that explores qualitative assessment proxies. So that's a fancy way of saying we use numbers and graphs to understand let's call it the social side of building these things in our context. And we basically mapped all of this data onto this framework, which leaves us with a specific segmentation size and geometry. Now, yeah, that can get very abstract. That's the world of computational design, I guess. But really the conclusion here is that if any of you in this webinar are interested in building segmented timber shell structures, then you have to know that it's optimal to use hexagons and not triangles in terms of actually segmenting this thing. And there's a specific size range of 800 mils to 1 meter in edge length approximately that works in terms of our laborers can actually carry it, and it kind of balances what is best in terms of wasting material and what is best in terms of the amount of segments that we start generating. So point is there's a specific segmentation size and geometry if nothing else made sense. And the second part of this presentation is about my thesis, where it's kind of a form finding journey for a train station in Johannesburg at Germiston Station. So what I've presented up until now is kind of efficient formation processes. So a bottom-up approach where we understand how do we build curved geometries in South Africa, and then only then we go to form making, where this flips the process on its head, because typically we envision some sort of grand form and then we waste a lot of material when trying to build it and rationalize its construction. So here form making is considered upon understanding formation, and this process uses a bunch of different tools. It starts out with physical simulation. So if you start hanging a cloth, how you get these sculptural and efficient forms, and then you start digitally simulating that. And the reason for the digital simulation is to understand how light falls into this station, because with large vaulted spaces, the difficulty is to not have this kind of shopping mall that's just artificially lit. So with this first iteration, you can see that light is not performing very well, and that underscores the importance of including the hand-drawn intent in this form-finding journey, because already just sketching this out and then going through physical digital simulations, we can kind of see a bit of a better performance in terms of how light reaches the interior. And in terms of physical simulation, as the design developed, it considered different techniques. So here I used soap film simulation, which is taking wireframes and dipping that into a soap mixture, and then that soap finds kind of the minimal surface to cover these wireframes, and it really expresses this biological pursuit of maximum performance and minimal resource use. So here the lighting became more interesting. That's kind of the proxy by which this form is assessed in terms of its appropriateness for the site. And lastly here, I tried to kind of fold open the shell, again using soap film simulation to see how light falls into this space. And the journey just continued with this kind of, fun and form making process. And the project kind of ended up here where, as the script evolved, as the project evolved, it ended up with these hyperbolic paraboloid shapes, again emphasizing that this is built using planar segmented mass timber elements. And what was interesting about this shape, it performed the best in terms of what I wanted for light in my project's interior. But the curved geometry of the shape now allows me to put some of the programs inside my station building, putting that actually into the shell. So the shell becomes habitable, which is kind of an unexpected outcome in my form finding journey. So I guess I can just conclude here to say that, architecture can make people dream, and beauty makes people dream. And this type of data-driven design and delivery process, combined with traditional hand sketching, combines beauty and intellect. And that's how we should understand natural systems, not from an aesthetic point of view, but really from a performative point of view. And I look forward to where my master thesis is going. Thank you for your time.
Again, another beautiful presentation, and thank you for recovering quickly from your technological whoopsies, but that's good. That's how we roll. Our next speaker is Leon Pienaar. He's a dedicated lecturer at the Department of Architecture and Industrial Design at Tshwane University of Technology, and he has over 2 decades of experience in architectural education. He specializes in integrating theoretical knowledge with practical application, fostering a learning environment that prepares students for evolving demands of the profession. Under his leadership, the Faculty of Engineering and the Built Environment established the M² Lab, built by MIT FabLab principals. The lab provides students access to state-of-the-art manufacturing tools, including industrial CNC machines and routers and fiber laser cutters, allowing them to experiment with plywood construction and complex design forms. I hope I can come and play one day. And then his recent supervision includes projects on urban integration in Mamelodi, essential community centres in Pretoria, wildlife reintroduction facilities in Dinokeng Game Reserve, and renewable energy solutions at Kelvin Power Station. So welcome, Leon, and it's over to you.
Thank you, Samantha. Am I audible? Everything good?
Everything we can see and hear, and your presentation is there.
Fantastic, thank you. I'm going to start with integrating Wiki House principles with open building concepts at TUT, and that would be promoting a sustainable and adaptable housing solution. It all started with the department's philosophy of TUT philosophy that we have, which is D2 plus M2 equals our graduates, which the D2 stands for design and develop, and the M2 stands for model and make. So with all the years across the board from first year all the way up, we use that approach. Just a quick background on the structure of our course, just to put it a little bit out there. It's a bit different to the other universities. We have a foundation level, which then helps students transition from the tertiary high schools level into the university level, and we actually had a good success rate with that, transcending into the senior years as sort of also a good way to get good students that might not necessarily have a good education on that level. So that brings us obviously to the People's University. And on second year in our group, so these are rings for years, and on the second year we have a big component that's called the work integrated learning component, where the students go out for 6 months and work in practice and come back and bring that knowledge back with them, and also gives us a bit of guidance and also link up with the practice as well. And then the last little part here is the 4th year ring, which is divided up in 2. We call that the Y split, and we've got a technological split and a design split. So the technological or tech students, as we call them, would have advanced building physics and systems. Mostly the word advanced and very technical. They've got more of that in their particular ones. 2 years ago, we had a concrete 3D printing master student that came from the tech side. And the design is typically the normal architectural theoretical way of doing things. So yeah, it was quite nice to see a lot of discussion and things on the student side, and I would just like to show this particular quote, which is something that's really cool from Buckminster Fuller, which I really like his way of thinking, and he was a futurist in the 1970s. You can say a lot about him, but the main one is, how much does your building weigh? A question often used to challenge architects to consider how efficiently materials were used for the space enclosed. And he posed this to many architects, and it's been around there for some time. There's also a lot of development on geodesic structures, on typical optimization, and resources of the world, which it's really awesome just to also know. He is definitely a lot of stuff you can learn from him and his writings. So we have in our school a makerspace, a design nexus room, a computer lab, a print lab, obviously a reading room, and we also integrate with architectural design, architecture and industrial design, which is a sister department. We are merged with them. We don't have the same architectural subjects, but we interface with the maker part that we will see in a moment. So overview on the WikiHouse side. So it's open source. What is WikiHouse? It's an open source digital building system designed to make affordable housing accessible to the general world out there. Alistair Pravin was the mastermind behind it, and it's been growing steadily growing. There's quite some stuff that has been built over the years, including this particular house that you can download, open source and CNC cut right away if you have the 18mm plywood available and the CNC. So it democratized the construction by enabling anyone to download these things. So, and that's really important because you can actually decentralize the manufacturing process. It's not a centralized one. We have one factory in Johannesburg and everybody needs to buy from that one factory. You can actually have CNC machines throughout the whole country, and you can start cutting in your community. And that also brings up a lot of other avenues of creating furniture and custom built stuff, which is really the ethos of the fourth industrial revolution, to custom build what the clients require. So it aims to lower barriers for home ownerships and lower the cost, environmentally friendly materials, obviously wood, which we all know what its benefits would be, and as I said, the open source and collaboration worldwide, where the information gets shared and developed, really makes it quite awesome to be part of this community. There is the WikiHouse web link at the bottom. I will also share that. So it's wikihouse.cc if you need more information there. So the key principles. So on a simple design, a sustainable practice such as using locally sourced eco-friendly materials. So if we have more and more wood suppliers and locally available materials, that will also push down the price for this type of construction. And we hope that can happen extremely soon and extremely fast. So use of CNC milling and other digital tools. So that would precisely cut the components that are easy to assemble. So that means that you don't cut the whole house and you have like 3,000 little parts and you build a puzzle. This system, the previous version of WikiHouse was like that, but with the newer version, it is more modular based or block based, where you cut basically, say, for instance, a column that's, say, 3 meters high, 250 by 250 millimeters, the width of it and thickness. And when you finished cutting all the parts for that column, you assemble the column and it becomes a building block that you can then place on a truck and deliver to site. So you'll see soon now what I mean with that, but then it makes it easy to assemble these structures. So then that is basically just an interesting example where you can actually put it on a flatbed and transport this whole thing. So looking at other theories as well, like open building frameworks, which really resonates quite well with the WikiHouse philosophies and stuff, which is promoting the levels and the prioritized long-term adaptability and adaptability for occupants to have a say in how their spaces function and evolve. This approach also makes it particularly relevant for housing projects like TUT's housing initiative, as it would align with the goals of the sustainable, user-friendly and resilient design. So modularity in design, adaptability through separation of systems, which is really crucial. If something needs to change after a while, that you don't break down the whole house to get to this pipe or thing you want to change. So user control for customization. You don't have to break down the whole house just to change the window. And sustainability and resource efficiency. So a lot more to say on that one. But moving along, so phases of the project, so just delving into where we are with the project and what we have developed so far. So there's a couple of phases. We started off by showing how Fusion 360 works with my students. So that wasn't my subject, the computer applications and architecture 4 subject, which covered both the tech and the design group. And that also then helped to develop many different designs from the whole group. And out of those designs, we chose the relevant one that we wanted to develop. So it also transcends into the other subjects as well to assist, because this is quite a real intensive project to build this year, but we did it at least successfully. So Fusion 360 was built, and we use technologies like computational design, where we use Dynamo scripting and things like that to assist us with creating these panels. And there you can see the blocks at the back being assembled. So this is just a slide showing all the students that participated in this project, and the one that was chosen, like I said, we had about more than 40 students, 4th year tech and design, and so they each had to do a concept. So we actually have 40 more designs that we can start cutting right away if we had the resources and so on. But this was the one that was chosen, and so the students obviously proposing their design solutions and collaborated between themselves with coordination with Dr. Emmanuel Nkambule, which is the 4th year tech coordinator for the year. And thanks, Emmanuel, for being there. The fabrication phase basically looked like this. We used the Fusion 360 platform from Autodesk to load in the model, and this model is freely available. We can also send it to anybody that's interested to have a look at it and measure or do and see how the space would look. In this particular case, it was a study nest, the sort of like one of those standalone things that you can build in back of your garden, just as to get some structure going. And this would also link to other rooms with a vestibule. That was the original design intent of the project. So the challenges that we have experienced, I mean, there is quite a lot of the resources. We have limited resources, but luckily we had some material from Universal Ply, the stock that we bought from them. So it's all the material you see as Universal Ply going up in a structure. So they had to CNC cut this model, but before we get to the CNC cutting, this 1:6 model was developed with the laser pre-cut first with the laser cutter that we have there at a scale of 1:6, specifically 3mm MDF then represents 18mm plywood. So they could then explore if there's any gaps in the design or parts that were blocks that were missing and that sort of thing structurally, because the whole part here at the bottom is of the structure, the floor and the walls to about lintel level is open source, and from there onwards the roof structure was developed by the students. So that is new to this development, or to the WikiHouse model. So cutting sheets were prepared and all of these things. And we also need to look at, obviously, our SANS code of practice on timber buildings. So all of these things also came into play. There's obviously still some development with these regulations as well. And how would the WikiHouse really be working with that, and definitely something that is still open for development and further research as well as we go about. And then also the structural capabilities of these things, which then brings us to this slide, where in the open source community, it has been already structurally tested. If you go to that wikihouse.cc link and you go to engineering, what is Skylark, it will tell you what it is. It will have all the calculations and the tests and research that has already been done with this particular way of building with 80mm plywood panels, structural panels. It would be interesting to also transcend that into eucalyptus ply, and hopefully in 2025 we can get our hands on some of that, and also then do our local testing in conjunction with University of Pretoria, their structural engineering lab in Future Africa, which is great, and also all our structural stuff at TUT as well. So to compare what the results would be and how strong the structure would be. But yeah, it has already been tested quite extensively, and it's very exciting to actually see that. It's not totally new, and it's been around for, yeah, I think more than 10 years now. So there we can see the laser cut model. The cutting files needed to be verified, because when you start cutting, you don't want to make a fault and lose valuable cutting material like the plywood sheets. So that's our in-house cutter, and the whole process took about a month to construct this structure. So yes, obviously if we can ramp this up and get more CNC machines and a larger place to construct all of these things, we can actually hopefully start cutting these things and get more structures out into the community. So just to quickly show you, obviously recycling our material, that's very important as we go through the material, and also that is then assembly in our makerspace workshop. And this is a passage from our crit room where I used it to stack all the components. So you can see the window components and then the wall components all the way down. So it's a building basically unfolded. Then we were also part of the Timber Construction Conference on the 9th of September. I just wanted to congratulate all the students, NMU for their first place, TUT, Yashin for second place, and TUT, Relobogile and Grace for their third place, and an honorable mentioning for University of Pretoria. I also would like to thank Carl Brand for giving us this opportunity, and also the conference and Skalk and everybody that we could exhibit in this space. This is the first columns that you did possibly see if you were part of that conference, and the furniture from industrial design. And like I said, we've got a massive link between the two industrial design and architecture, and so also transcending that into the master's program as mentors. So they are really integrated into our architectural department as well, and really helps to realize these projects. So currently, this is what we have. We have this foyer in building 2, and you're more than welcome to come and visit. You can just let me know. I'll definitely take you through there and show you all the workshops and things that we have and projects that we are doing. But this is the front part, is this roof, the sloped area. That roof is supposed to go on top there, but the height, or the soffit height of the bottom side of this venue foyer is just too low, which is about 3.4 meters currently from ground to floor. So we just need a bit more. But what we wanted to do is not put this model out because it's now the rainy season and it will damage the structure. So before we do that, we need to get cladding on top of this thing, and we have already a couple of sponsors, and if there is anybody that from industry that would like to partner with us, Everlast is already showing some interest, and I think that we'll definitely have some talks from industrial design. Spoke to York as well. We're already in conversation with Universal Ply, because I know we've been buying ply from them for a couple of years. So the conversation is open, and also from Skalk side, timber chair. So that's the internal space. It's about a 4 by 3 meter space, and the windows were developed to accommodate standard windows. So that is still something that will further be developed, and that you can buy standard stuff from builders and integrate it into the structure. Right, funding opportunities, so material and building space. We're obviously bursting out of our seams, and we need some sort of shed, warehouse, whatever, to get things going. So if there's any ideas or solutions for that, that'd be great. There's a lot of space on campus to build something like this. We have many departments that can benefit from something like this, and also industry that will also benefit something on focusing on housing solutions for this, and then bringing that back into the community. So just in summary, future steps and contributions, there's my email address if you need to talk to me, and send me a mail, more than welcome. And please do come and visit. Thank you very much.
Thank you, Leon. Very interesting, and thank you for all the work that Tshwane University of Technology is doing, and it's always great to see industry and cross-university collaboration. So we do have a few questions for Leon and for Shannon and for Nicola. Bram de Villiers has a question. For Leon, do you think that most of your students that exit the MProf level will be able to use digital tools and digital software to design their building designs? Or design and build their designs?
Yes, Bram, thanks for the question. Nice to have a question from your side. Yes, that's the idea. I mean, we can see a lot of development of this happening. We have been ramping up for the past couple of years on computers on the computer subjects to get more computational design going, to have more sustainability calculations going, and really get our students grappling with these things, because there's a lot of potential of working faster in this environment, as you would know, with buildings that you may have done through your office, and if the efficiency can become boosted, that hopefully will leave more place for creativity. As we know, getting to that point, it takes a lot of learning and experience and testing. But with this type of scenario where we have an opportunity for architectural students to actually build architecture, even if it's just the basics of architecture, it's really empowering us to get back into the weeds of architecture, which I really love. It brings it back where architecture was originally. I don't know if that answers your question.
Yeah, question to Shannon. That's basically maybe more of a pointer. Shannon, have you considered the flexible nature of Zulu construction? I mean, timber does not have to be straight machined, sort of orthogonal type construction. Timber can bend. And of course, don't forget the way in which the traditional Zulu hut, the domed hut, was made. The frame of bent sections of timber tied together was erected by the men, and the woman came along as a separate specialization, and in fact thatched and wove the coverings. There's maybe a lesson there that you can think about in terms of a more flexible, more, I suppose, organic form of architecture at the end of the day. We don't have to build square rectangles all the time. Surely with timber we can in fact adapt and look at more curvaceous structures. Anyway, that's one thing for Shannon. The other thing for Nicola is, Nicola, I think we also need to learn, terrific, yes, we must learn skills from elsewhere, and certainly high-end skills, but we also need to learn middle-level skills. And I think you need to maybe think also about looking at building craft, building technology in Indonesia, Malaysia, and in the Middle East, Iran, where there's a lot more curving and more robust jointing, possibly. Anyway, thoughts there. My final question is to all of you is, what on earth are designers architects, including myself, and all designers doing about promoting the growth of indigenous timbers in our country? We've rather forgotten about our wonderful range of indigenous timbers. There are at least 20 to 30 wonderful indigenous trees that can be used for construction and for furniture, and we're not promoting it. We're not requiring our farmers to allocate at least marginal land to growing indigenous timber, and we're still importing, and we're importing more and more stuff from Europe, from the Far East. We're importing rubbish, to be quite frank, from a lot of Far Eastern countries. The bala we're getting here is really third or fourth grade, and I'm afraid so is the Moranti. So let's think a little bit about promoting the re-establishment of indigenous forests, maybe in a plantation format with 10 or so trees varying in accessible plantation format for future harvesting when our grandchildren need to build. Anyway, thank you very much. That's me done.
Yeah. Let me go to Dr. Krobla's question. Nicola, are you planning to build a scale version of your project?
Thank you for your question. So as I approach the end of my master thesis, I'm planning to build a kind of a scale model of the final kind of the form product of the train station that I am designing. And I have a few scale models of the kind of the smaller, when the research was just about considering shell structures, not considering how do we build train stations with this technology. So I have a few models in terms of that, but I will be building a very small scale model for my thesis defense, but it is it's at a scale like 1 to 200, 1 to 100. So it's not there yet, building with like, let's say plywood or something like that, where we really get to like scale 1 to 10 or 1 to 5. But on that note, that would be amazing. I think if we can get to a point where we can actually start building scale models that's not paper models, architecture paper models, but really demonstrated pavilions, I think that's really a critical step in making this building system, kind of marketing it to the built environment. I hope that answers your question.
Yes, thank you, Nicola.
Thank you, Nicola. And there's another question for you from Brahm. And it is, in your research, have you worked with structural engineers to develop the structural models for the shell structure layout and the calculation for the structure?
Also a very interesting question. Thank you very much, Brahm. So we have a lot of international case studies now, like the Buga Pavilion, which is my favorite one, that shows the structural validity of this. So my research was a bit more of saying, okay, we know this thing works on kind of age-old structural principles such as catenary action. So how do we make the construction of it more regional? So an important part of the step would be to work with an engineer where we kind of understand where the flow of forces are, so that we can, in that script that was developed to nest these planarized panels onto mass timber panels, you would script in a step to say that each panel that's now in this digital model has to align with the major strength direction of the mass timber panel. So what I mean by that is every segment has a major strength direction, the kind of the direction in which most of the timber grains flow, and that has to align with the major strength direction of the panel. So yes and no, indirectly, I haven't worked with a structural engineer, but what we have to do is, as a next step, kind of understand how aligning those major strength directions work.
Thank you, Nicola. We do also have a question around how does the costing compare between a timber structure versus a typical brick and mortar or brick and concrete structure? Skalk, are you able to answer that? Or even, I think Brahm can answer that. Let me just enable your microphone, Brahm. It's just... Okay, Brahm, you should be able to unmute and answer the question.
Thanks, Sam. I think Skalk can also give some input, but I think there's a lot of different groups at the moment. The one is CLT, cross-laminated timber, and GLT structures, which has been in use in the country for a number of years. And I think at the moment in CLT and GLT, it's still slightly more expensive than brick and mortar. But I think as we get our efficiencies up, meaning that we can quicker or not efficient, that we build more in CLT, the cost will definitely will be comparable. There's been a very interesting study done by MTT Marcus and them to compare a multi-story office block, and they've really got it down to they could build a CLT building, or it's a hybrid of concrete and CLT panels. They can build it now comparatively at the same cost as a concrete building. So they've done those studies, and it's a very interesting study that you can get from MTT. On the plywood side, and where we are ourselves are working in, we can definitely comparably build to the same kind of square meter cost as brick and mortar. And then on the frame timber construction, the places where Werner Slobber and those guys are playing in, they definitely building at the same prices as brick and mortar. And when you're talking about sloping sites, timber buildings will definitely be more advantageous at cost than brick and mortar concrete structures. So I think the more that we're going to start building in timber, the more you're going to see those prices aligning with brick and mortar prices, and even, as I say, on sloping sites, definitely less. Maybe Schalk can also just give 1 or 2 cents worth of that.
Yes, thank you, Bram. No, I fully agree with Bram. Our research has demonstrated the same. We also recently did a comparison of an affordable house and a medium income house with brick and mortar versus timber frame. And in both cases, the timber frame was cheaper. But when you look at the walls specifically, it was pretty much the same. So it was within 10% of each other. But where the difference did come in, especially on the medium income house, is the foundations. And the specific case study was on a sloped site. So I think when it's still on a flat site, timber frame and brick and mortar will be, it will probably depend on who the contractor is. That will probably have a bigger influence on the cost. But like for like, it's more or less the same. And then if it's slope sites of poor ground conditions, then timber frame has got the advantage because it's a lighter structure. So yeah, that's what our research is currently indicating. But I think, like Bram said, it's important when it comes to, let's say, commercial or multi-story buildings, is that one rather go for a hybrid solution, because in some aspects a mass timber would be cost effective, but in others it's not necessarily yet. But as we improve our efficiencies, I think it will be more competitive.
Thank you, Schalk and Bram. I think, Jan, it's a comment that Ken notes is around the construction side, and the prefabrication under controlled conditions is also probably a factor. Is that correct?
Yes, Sam, I think definitely it has to do with the way that the contractor is building. And definitely there's one kind of contractor that sort of, let's call it, that systemize and optimize his construction system and building methods. And that's the kind of guy or girl that needs to build the building. Not so you need to have that, let's say, prefabricated mindset of the contractor side to really make a modular building that can really, then modular building can outperform standard, let's call it, brick and construction or concrete structures.
Thank you very much. Thanks very much to all of the people who interacted with us, and I hope it's been beneficial. Just before we wrap up, I'd like to have, Skulk, do you have something to add?
Yeah, sorry, I'll just want to ask Ken to drop me an email. I would like to talk to him about the indigenous options. Maybe there's something we can put together and put a plan together. So I'll drop my email in the chat box, Ken, if you can just send me an email, and then let's see where the discussion takes us.
Thanks, Scott. Would love to.
you.
Thanks so much.
Thank
Drop
you.
me a line. Thank you.
Great.
Bye-bye.
Thank you. So just before we close, I'd like to introduce Roy Southey. He is the Executive Director of Sawmilling South Africa, just to give us some closing remarks.
Thank you very much, Sam. I think it's just left to me to say thank you to everybody today, especially to the presenters, Shannon, Nicola, and Leon. It's really encouraging for me, having been involved with these webinars from the inception. It was an initiative by Sawmilling South Africa about 3 or 4, maybe even 5 years ago now, that we started these webinars. And on the first webinar, I think we had 27 participants, and I see today we had over 90. So it's growing tremendously, and I think the first thanks should go to Samantha, who came on board very early in the process and has taken us to these new heights. So thanks to you. Also, thank you very much to Fadzwa from the DTIC, who has been with us all the way and has ensured and insisted, in fact, that the webinars and the promotion became part of the overall forestry master plan. And we've enjoyed the most wonderful support from the DTIC. So thank you to Fadzwa and her team. And then, of course, these sort of days would never be possible without sponsors. So to Brad Anderson and the people from Universal Ply, thank you very much for stumping up the money for today's webinar. And really, other than that, we don't have anything else to say, except, as I said in the beginning, thank you very much to Leon, Nicola, and Shannon. It's really encouraging to see that the young people are taking the bull by the horns and are running with the process that we started 4 or 5 years ago. Again, just to mention that when we did start this, the rest of us were all a bunch of stuffy, fuddy-duddy old men, and it's really great to see that the youngsters have taken over from us now, and we wish you everything of the best going forward. Thank you, Sam.
Thank you, Roy. And again, yeah, thank you to everybody who participated. Thank you to our attendees for joining us. And really, it is exciting to have just the young blood on board. I see Gerard from FSC, Roy has said, speak for yourself about being old. So really thank you, Roy, also for your contribution to making these webinars possible. And I can't not thank Ferdinand Hassan, who is the engine room for our webinars, and really appreciate his support. So with that, thank you so much for your attendance. And please have a look at the links if you haven't already. And if you need any questions or you have any questions, I think you've got our email addresses. So thank you and goodbye.